Hi, this is Randal Schwartz, host of Floss Weekly. This week, Aaron Newcomb joins me. We're going to be talking about crate data, which is like a weird mashup of NoSQL and SQL. Scales well, SQL interface you're familiar with. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by CacheFly at CacheFly.com.
This is Floss Weekly with Randal Schwartz and Aaron Newcomb. Episode 305, recorded August 20th, 2014. Crate data. This episode of Floss Weekly is brought to you by Hover.com. Hover is the best way to buy and manage domain names. It's simple, honest, and easy to use. For 10% off your first purchase, go to Hover.com and enter the promo code FLOSS8. That's FLOSS8. It's time for Floss Weekly, the show about free, libre, open source software. I am your host, Randal Schwartz, Merlin at Stonehenge.com, bringing you each week the movers, the shakers, the big projects, the little projects, projects you may be using every day and not aware of it, projects that might sound really cool and you might want to download right after the show and go play with. Joining me this week is Aaron Newcomb. Welcome back to the show.
Hey, thanks, Randal. Good to be here.
Cool. It looks like you're in the brick house.
In the brick house, sporting my Twit gear.
Exactly.
I'm all in the groove this morning.
Yes, cool. And I'll be up there actually in the end of the year. I'm going to be part of the New Year's Eve celebration for that, so it'll be a lot of fun. And
cool.
Maybe you'll come by and we'll see each other in face-to-face again for a change.
Yeah, I'm planning on coming. It was a lot of fun last year. I did all about Android. Are we going to do a Floss Weekly this year? I mean, I know it's probably off schedule, but...
Well, yeah, we'll see what my condition is midway through the time slots there. It may be that I won't be able to do a show with any kind of regularity there or any kind of, without being, well, given some of my recent shows, it probably wouldn't be much different. Anyway, I'm at the usual place in Santa Monica. For those watching the video, you recognize the tree behind me. So this is, thanks again, courtesy of my current major client. And ZipRecruiter. I'll just put their name in there real quick. Anyway, but the show isn't about us or about our locations. The show is about open source software. So this week, no exception. This week we have, I'm going to mispronounce his name, and when he comes on, he can explain how to pronounce it correctly. But I think it's something like Jodok Batlogg, or maybe it's Batlogg or Batlogg or something. Anyways, close to that. And he's representing the Crate Data Project. And I'm really excited by this. We saw these guys, chatted with these guys a little bit at OSCON, and it's the holy grail. It's scalable SQL. So there's a lot of solutions that use NoSQL, and they can scale and shard and all those cool web words and things like that. But every time you get to an SQL solution, you got to figure out smart ways to replicate your data. There are multi-master solutions, things like that. But this looks like it's the intersection of those. We have an SQL interface to be able to, using standard SQL language, and yet it scales and it's self-repairing and all sorts of wonderful things like that. Aaron, have you had a chance to look at the notes on this yet?
Just a little bit. I mean, so I'm interested in compare this both to NoSQL, but also to relational databases, because those obviously scale really well too. You think things like Oracle or Postgres. I mean, there are databases that are really, really large. Especially when you start talking about data warehousing and some of those things. So, and then you get into analytics. And so I'm really kind of curious as to how this plays in that world.
Well, that's right. I almost forgot that you worked for a very large company that did large databases. So this should be really apropos.
Yeah, absolutely. I mean, this is a big part of my day job, is working with all things Oracle and helping customers figure out how to implement their Oracle databases, get better performance, deliver better response time to their users and things like that. So, so I've got probably a pretty good perspective on this, and I'm interested to see how this would help solve some or any of those problems.
Very good, very good. Well, just before we get started, though, I'd like to announce that we have a sponsor for this show. It's Hover.com. So when you have a great idea and you want to secure a domain name for it, you want something catchy and memorable to represent your online identity, Hover gives you exactly what you need to get that done. You'll find the perfect domain for your idea so you can get started working on it. And the important thing now is that right now, Hover is having a sale on all new domain extensions through September 1. This sale is for new and existing customers. Summer's the perfect time to start a new project. Every single new domain is deeply discounted, so you can choose whatever you like. .club, .ninja, .guru, .just about anything. People love Hover. Geeks, developers, designers, and programmers love Hover because they know they'll have the best tools and support. But you don't have to be an expert to get a domain. The service is simple enough to use. And I know all about that because I just registered a couple domains through Hover, so I'll talk about that in a minute. And it's very easy. Just search a few keywords, and Hover will show you the best available options and suggestions. Hover is a clean and simple website. In less than 5 minutes, you can find the domain name you want to get up and running. Also, this is important if you have existing registrations. Hover offers a valet transfer service to make the process completely painless. For free, Hover will take care of the entire process for you and let you know when your domains are settled into your Hover account. They'll transfer all your DNS settings, and no matter how many domain names you have, it's no additional cost. Hover is honest. They don't believe in heavy-handed upselling. They'll include everything you need for your domain, no more and no less. Plus, they also include a custom email. You get a smart control panel so you can do what you want with your domain, plus Whois privacy is included free on every domain that supports it. And if you ever need it, Hover has the best customer support around. It's known for its no wait, no hold, no transfer phone service. When you call, the real person is ready to help. And Hover also offers volume discounts. They'll give you a discount on your domain renewal starting at just 10 domains and going up from there. The idea is the more domains you have in your account, the less you have to pay to renew them. So here's the offer. Visit Hover today to register your domain name and for 10% off your first purchase. Take advantage of their summer sale. So go to hover.com and use our promo code FLOSS8. I just did that. I got 2 domains just moments ago. RandalSchwartz.info, spelled with 1 L and 2 L. And I got it for about $16 for the first year. Really, really cool. So I'm going to have an address eventually of me at RandalSchwartz.info. And the nice thing about having both domains is that whether you spell my name correctly or spell it wrong, or you spell it with the middle initial, it'll still work. That's so awesome. So we do, in fact, thank Hover for their support of Floss Weekly. So let's go ahead and bring on our guest, Jodok Batlogg. Welcome to the show.
Hello, nice to meet you guys.
Yes.
And actually,
yeah, go ahead.
Yeah, my name, it's Jodok Batlogg in Austrian language, and it's SEO optimization. So I'm very easy to Google as there's only one person with this name on the planet. So that's my story.
Nice. So Jodok Batlogg, closer?
Jodok, yes.
Okay,
that's
and
much better.
Where are you speaking to us from?
I'm based in Dornbirn right now in the Austrian mountains, but usually we also have our office in Berlin. So today it's Austria.
Cool. So you get around a little bit, I can tell. So I gave my impression from just skimming for about an hour the website and the docs. Why don't you go ahead and give us the 30,000 foot view and describe the problem that Create Data is solving?
Yeah, so we're coming from the world of distributed systems. We really believe that everything, all data persistence is going to be distributed sooner or later as data is growing tremendously. And you cannot handle this on a single machine, not only because of reliability or because of space or scalability. It's a number of various reasons that require distributed systems. So every average developer will also need to be able to handle millions of events or documents or records in a database. And as we've been working with clients in that space and using this technology for several years, we've been following most of the trends, like the NoSQL trend, and we found this pretty convenient. But at some point, we found that all of this stuff is being complicated. You ended up in managing a zoo of technology, having a document store, having a search engine to accelerate it, having queue systems interconnected that, and we just wanted to make that stuff much more easier for an average developer to use. And that's why we started Create a few months or almost 2 years ago, and decided to build this open source project based on existing libraries like Facebook Presto or Elasticsearch, Lucene in that space. So what Create offers is one package that is very easy to install and very easy to use, that provides storage for semi-structured records and blobs, a SQL interface, and easy scalability where you don't need to worry about sharding and replication and stuff like that.
So am I interfacing with this then using a standard SQL language and then using that to insert the data and update the data and query the data?
Yeah, right. So we're big fans of Postgres. That's what we're using, what we've been using beforehand, and we are trying to be as close as possible there. So we're pretty complete. The big thing that is obviously missing, or not obviously, but that is missing right now is joins, which are heavy to do just because of the physics of the data. But other than that, we are pretty. We are in pretty good shape, and we are adding functionality whenever someone is filing a GitHub issue that some functionality is missing he needs. We're gonna add this pretty fast.
Now, when you're saying you're missing joins, that means you can't select from two tables at once yet?
Yes, you cannot do inner joins or outer joins or a number of variants you need to do with joins. You need to store your data denormalized. That's what you need to do in a NoSQL database anyway. But as that being said, we're also working on implementing joins, at least some subvariants of joins. So the topic about joins is, if you have a large table with millions of records and another table with millions of records, and you join them, then this is something that is physically sometimes impossible. And everybody that is building scaling systems is not using joins. So we found that this isn't a major restriction right now.
Okay, that's interesting. Cool. Did you get inspiration for like the replication and the sharding and things like that from any particular existing NoSQL solution?
Yeah, so as I said, Elasticsearch before, that it was like our the thing we looked at most, or where we were excited about most, about the simplicity, about how easy it was to scale and to configure. And that's also what we're using as a library under the hood for some parts of our system. But that being said, Elasticsearch is not a data store, it's a search engine. So on the document storage level, it's more we are focusing more towards SQL databases. So we want to have something like MySQL or Postgres. And then we have, for semi-structured objects, we have an object column that is probably like a JSON field in Postgres, where you still can use unstructured data, and also like normal JSON documents that can be stored in the database. So we think that pure NoSQL is an overreaction. We think that schemas have a huge advantage later when reading data, when processing them. But still, there are some cases where you don't want to have everything in a hard structure. So semi-structured, I think that's the way to go.
So is there anyone else? Because this seems pretty unique. I mean, you mentioned that there were other, if you want to do this on your own, you have to kind of cobble together a bunch of different things. And we talk about relational databases and Hadoop and NoSQL. I mean, it seems like you're kind of trying to tackle or solve world hunger when it comes to database implementations and the way that we think about and use databases. But is there anybody else that you are kind of competing with? Is there any other companies that are working on a similar sort of initiative?
So we are not aware of a direct competitor. There are a lot of databases in that space of NewSQL or distributed. So some companies we see are Hadoop accelerators, but they are more on an analytics workload. So we focus probably on a read-write workload. But if you just want to make Hadoop faster and use a SQL interface, there are a lot of initiatives there. Spark, for example. Other guys like FoundationDB or Exasol or whatever, they are on a highly transactional distributed system. So they try to be ACID compliant, heavy transaction, and that space. We are still eventually consistent. We are using advantages of the NoSQL databases, but we provide SQL as a language. So we are using most of the NoSQL features like availability, partition tolerance, cross-data center replication, but we provide a SQL interface that allows to use standardized tools to access the data. So I think this position is pretty unique.
Yeah, like I was just thinking, what about, you were talking about you can't do joins. I think that's going to be, for someone that is coming from a relational database background, I think that's going to be a big limiter. But what about things like data compression? Are you able to do, because I can see that if you adopt this model that you've proposed here, I mean, it just seems like the amount of data that you could store is going to be huge. I mean, people coming from like an Oracle background, they typically don't like to store documents in the database, although Oracle always says, oh, use Oracle database for everything. They don't like to have big documents and things like that kind of clogging up their database, if you will. But if you are going to have this, all your documents in here and all of your normal data in here that you're collecting from customers, let's say, it just seems like it could grow out of control. I mean, how do you, first of all, do you offer compression? And then secondly, how do you scale this thing?
Yeah, so we encourage people to store all their stuff in there, including binary objects. So binary objects are stored directly on disk. They are not somehow inserted in a database file, whatever. They are stored under their SHA-1 hash in a user space directory that is just split across multiple partitions or on one partition. And the rest of the data is being stored in Lucene indexes. So they are heavily optimized. They are also gzipped, compressed when they are written on disk, and we create replicas over the network. So we don't encourage people to create, for example, a RAID system of their 4 disks in one single machine and then expose them as one volume and use it for a large log file or multiple transaction logs. It's rather that we just expose, for example, 4 partitions, and the system is just using them and filling it up with different shards. So every shard is like a small database, and you can even hold multiple shards on one machine. And it's just that one shard is contained on one subdirectory. And then these shards can be replicated across the network. So it's very easy to scale out. So let's say you have 5 or 20 or 100 machines, and you just expose the disks to the system. Then you can specify policies about how this shard should be distributed across the machines and how many replicas you want to have.
Are you taking cues from Hadoop in that regard? They have HDFS, which is different than other file managers, although it does a lot of the same functions, some of them limiting. Are you taking cues from them? It sounds a little bit like that, where you're basically saying, here's your volume or here's your directory I'm going to point you at, and the database itself is determining how it's going to be used, as opposed to having to do a lot of data management in the background, which is more of the traditional approach.
So we don't expose a POSIX-like file system to the user. We provide for binary objects, it's just like a key value storage where we don't look into the content. And for the rest, like for the metadata, we provide normal database semantics. So for the user, it's just a series of HTTP endpoints. You can talk to every machine of the cluster and just issue the request to it, let's say stored as file, give me that file, and the system in the background will make sure that the data is being stored at the correct place or also being read from the correct place. But towards the user, we're just exposing a SQL interface. The manager or the administrator in the background, of course, he can take a look at the quota of his files, how full the partitions are, where are the shards located, and stuff like that. But for the user, it's transparent, and he doesn't need to worry about that.
So this is truly a distributed system then. There's no head node, for example, that has to manage where all the files are. Each system is doing that independently.
Yes.
Combined, so every, like you said, no matter which system you query, it's going to know where that file is that you need, or that data is that you need.
Yes, all nodes are the same. It's the share nothing principle, and there's no master node like a name node in Hadoop, or a secondary name node, or a job tracker, or task tracker, or data node, or Hive node, or whatever. We just have to create daemon that is exposing a HTTP interface or a UDP interface for a more optimized protocol. But other than that, the nodes are the same. To be honest, below there's only one thing where we have a master election, that there's one node that is master that can be elected to make some decisions, but this is not configured. So the master is also changing in the cluster, and if one node is probably going down, that's a very easy thing where the nodes decide who is like a master node, but there's no special function connected to that node. So yes, the nodes are the same.
Wow, this is sounding better and better all the time. It really does sound like the best of both worlds.
Thank you.
From my standpoint, at least, because you're solving problems that exist in the various implementations, how people get to their data, and I think this is sounding really, really good. We do have a couple questions from the chat room before we get too far in. One person says, "Does it about views?" I think he means, "Does it support views?"
So right now we don't have views, materialized views, or whatever you call them. You just have normal SQL queries. What you can do is you can do a select into, where you basically have the possibility to store the results of a query into a new table in a distributed way. So let's say you have a huge table with 500 million records, and you do something like a view or a query that is calculating 100 millions of them. You easily can store them in a new table, and the system is doing this in a distributed way.
Another user asks if the files are partitioned into multiple folders or if they're dumped into one single folder. I think you answered that, though, before.
Multiple folders, yes.
Right. And does the data have to be relayed to your request machine, or does the client library get a redirect?
So the client can connect to every machine. Usually you just use HTTP round robin, or if you install Crate on the same machine as the application server, you just connect to localhost, and then you just talk to that machine. When delivering binary files, you might receive a redirect to the machine that is holding the binary file, so you don't need to pump the data twice through the network. But other than that, you don't receive a redirect, you just connect to the node you want to connect. The Java client has the possibility to have a more advanced connect. He already knows about the routing algorithms according to what parameter the data is being sharded, and can talk directly to the client that is holding the data. But this is just like a small optimization. Usually you don't need that.
Yeah. How do you keep the system, how do you keep one node from getting overloaded? Is it, I mean, the best practices here, and we should probably talk a little bit about implementation, are the best practices to have some sort of a proxy in front of all your nodes to make sure that requests are getting distributed evenly, or do you not need to even worry about that?
You could use HA proxy in front to load balance it if you want, but you even don't need this, because the overhead of just receiving the HTTP request and then transporting it to the correct node, that is not generating a lot of load. So it's based on NetI, this asynchronous non-blocking I/O framework in Java, which is super fast and very efficient in doing so. So we haven't seen one load being overloaded just by having to handle all the connections. So it's pretty easy to hold 10,000 of connections on one single machine. So usually disk I/O is the limiting factor if you do that stuff.
Right, right. Now, I mean, this seems to be a little bit of object storage. I mean, it solves the problem or the same problem that object storage came along to address, or part of the problem, right? Which is you just store this as an object, and you don't really have to care so much about, you know, what the file's called and things like that. It just kind of goes through the system. It seems to address some of that problem as well. Do you find that you get people wondering if they should go with this or go with more of an object storage approach? I mean, it seems like from a programmatic level, you know, programmers tend to favor object storage over physical, well, this is really virtual, but file storage or data storage.
So a very good point, because we also think of this object model. So like in Python, you usually deal with an object relational mapper. So when building your Django application or whatever, you don't want to deal with just a row. So what we do, and that's also part of our focus, is to invest work in these object relational mappers. So you can easily use, for example, SQL Alchemy, which is one of the broadly used Python wrappers to connect to Crate. Or you can use Ruby Active Record to connect, or you can use a JDBC driver. But the good thing is that these tools to work in a programming language with an underlying SQL database, that works pretty well. And we found that this is a very good match, for example.
So if I wanted to get started, and then I'll let Randal jump in because I know he's got some questions too, and I'm monopolizing the time a little bit. But we need to cover this for folks that are, okay, now they're interested, right, and they kind of want to try this out. If you want to try it out, what's the best way to actually go about setting this up? Could I do, are there packages, simple packages I can install, for example, on Ubuntu, or is it Windows compatible? I mean, talk a little bit about what you need in order to actually get this set up and running.
Yeah, so all you need is Java installed, Java 7. That's basically the only prerequisite. And then on our homepage, we have like a bash script that is very easy to try. So you just paste it to your command line. It's downloading, unpacking, and starting the daemon. And then you have your daemon, then you have your machine running. If you want to build a cluster, just make sure that you're in the same network and via multicast, two nodes are connecting automatically. So I think running a cluster is just a matter of a few seconds in your local network. We also have pre-built packages for Ubuntu. So that's in there we are in the public repository. So you can install it with apt from Launchpad. And we also have RPMs for Red Hat distributions. And I think we have Arch Linux because some of our developers are Arch Linux fans.
Yeah, of course. Yeah, I mean, you always, I don't want to call them outliars because those Arch guys are special. Let's just say that.
Yeah.
They're passionate about it, and that's good. That's good. That's the way the Linux community grew up, and that's the way it should be. So that sounds pretty simple. Do I need to worry about, is this CPU intensive, memory intensive? Obviously, it could be I/O intensive based on what you're storing in the database. So, I'm almost hesitant to call it a database now that you've explained it, but I guess it is a database. What kind of resources are we looking at here?
Yeah, so the short thing about the database, so we call it the data store. We also found that database is too short because we also store binary stuff in there, and we do advanced full text search and things like that. So we call it the data store. Regarding resources is typically it's IO bound because you cannot hold all the stuff in memory, and you don't want to hold all the stuff in memory. And other than that, you should have some memory. Let's say usually 16 gigs of RAM are fine to hold the index structures in memory. Java, you need to configure the heap memory. And we are very efficient in garbage collection and stuff like that, which we want to avoid. So generally speaking, what we have seen is most of the applications are I/O bound, and it works best on SSD disks if you have lots of traffic. Other than that, the resources like CPU or memory are not so heavily utilized. So we actively encourage people to install it with their app servers. So I am also having a talk on one conference, can't remember, where I say no more database servers, and we just say install the app and the data store on the same machine, because the data store is going to use your disk I/O and the application server is using your CPU and memory. So yeah, that's our take on that.
So we actually had another question from the website, not from the website, from the chat room. There's all sorts of things. The web is just talking to us. It's loud. It's really amazing. Yes. So Retro D asks, the Crate website says it's document oriented. Is that you talking about the fact that we can store JSON as data, or do we need to parse it in and out as JSON, or does it just work?
It's using JSON in the HTTP protocol. We're using the body where the data is being transferred is in JSON format. So that's why we call it document oriented, because we also allow semi-structured records. So Yeah, that's basically where we are most close to the document-oriented stores.
And I think what you're trying to talk about is where you can say that this particular row, this table has column A that's an int, column B that's a text, and column C is actually a structure of maybe another int and another text. And I saw some syntax for drilling down into that. So if I understand this, I send that as sort of like one big JSON object or something that looks close to a JSON object. And then does Crate take that and then populate it in the right way internally then?
Yes, you're using normal insert statement, insert into whatever values. And then you can also use square brackets to drill down the tree structure of your content. So, but by inserting, of course, if you do bulk insert, you probably have a large file with one JSON line by JSON line, and then it's just being parsed and inserted. But actually, it's normal columns like you have in a SQL database, except that some of the columns are nested JSON objects and not just flat objects.
That's cool. Can you build indexes on the sub objects or just the primary ones?
No, all fields are indexed by default, and you can also do all operations on the subfields. Some operations are limited. If you do arithmetic functions like counts or max or min, then there are some specific cases where we deal differently in nested objects. But generally speaking, we use them as full-fledged.
Now, when I actually enter a query, is that sent like to all the nodes, or does it know which nodes have a particular table? And so is it like oh god, I forget the word where it's like gather, MapReduce. So it's like MapReduce where it goes out and does the thing and then join those all together when the results are already?
Yeah, so it depends is the easy answer.
Okay.
It's our query planner. So quite a lot of ours, as I mentioned, we're using quite some open source libraries to build that stuff, like the SQL parser from the Facebook guys, like Elasticsearch for cluster, Lucene for storage. But the query engine that is building these distributed queries, this is much of our knowledge. And so if you do like a group by or a distinct count over a large data set and you want to group by one column and calculate the sum, then it's doing a two-step approach, which is like MapReduce, but just in real time, where it's doing reshuffling of the data. If you just do a full text search, it's like scatter-gather. Or if you just request one single object, then it's just doing a get. So yeah, it's basically using whatever is needed by the query.
And you mentioned earlier that this was, using the standard sort of NoSQL sort of backend logic about eventual consistency. So if I create 3 replicated copies of a particular table, does the query that I send in right after that go to just one of the replicants, or does it go to all 3 and there's some voting, or what?
By default, it's using the primary shards. So in a normal environment where that is not too much heavy read-oriented, you have enough performance by just reading from the primary shards, and you usually use the other shards for safety. So the default setting is you query the primary shards, the other ones are being written delayed, but you can also configure it to write it synchronously, that the call is just coming back after all the shards are being persisted, or you can also specify that you want to query also non-primary shards. We are read after write consistent. So if you write a single record and you read it immediately afterwards, then you are 100% consistent. It's about search queries and stuff like that are eventually consistent.
Okay, great. That sounds cool. And the follow-up question, a different question. It's not a follow-up question, it's a different question. Someday they'll let me actually learn how to do the show. It's going to be fun someday when I finally figure this out. Like that one show I did where it was like, I've got 2 questions, but then 2 more questions after that. That was, oh, what a goof. Anyway, so, and now I forgot what I was going to say. Yes, if I have 3 replica copies, if the primary one goes down, obviously there's going to be some shuffling to try to repair and get back to the 3 copies, correct?
So immediately after the one copy is being lost or being marked as corrupt or whatever, the system is turning its state to yellow. That means that not all of the criteria that is specified regarding safety, data availability is being met, and it's struggling hard to make the system green again. So it will immediately create new replicas of the Schwartz and on another machine, and then turning the cluster back to green. This is happening automatically.
And in case of a simultaneous failure, let's say you had all your tables were replicated 3 times, could you take 2 machines down at once and still have this work?
Yes, absolutely. That's no problem, and that's what we're also simulating. So at our if we are on a conference or on our booth, we have a small cluster where we have just 5 Intel NUC boards, which are like bare bone machines, where we just disconnect the cables and shuffle around and show actually how this works. Of course, you need to tweak some timeouts because this does not happen normally in a data center. So you probably will have to wait 10 or 20 seconds. But for demo, you can also configure it to 1 second, and you really have this effect of unplugging it and immediately start self-healing. That's one of the key points what we're doing.
Very good. And you mentioned earlier also cross data center replication. I understand that you're doing multicast. Does that mean I need to set up a virtual network so I can multicast to the remote data center?
So you can also configure to unicast. Then it's not like automatically forming a cluster. Then you need to specify the list of nodes that are part of a cluster, and then they are connecting via unicast. That's no problem.
And can I request, when I'm saying replicas, to try to keep the copies in the other data center?
Right now, you need to do this under the hood. But just today, we had our Scrum planning. So we're working with Scrum. And this is a feature where we expose over our settings interface, where you can specify the policies, let's say in which availability zone or in which rack awareness you want to place the replicas. You can do it right now under the hood with private APIs, but hopefully in 2 weeks on the nightly build, we're gonna have it also exposed over the SQL interface.
Well, you heard it here, folks. First, it's a scoop. It's exclusive. They just announced a new feature right here on FLOSS Weekly. That's why you tune in every week.
Yeah, that's because they haven't had time to announce it anywhere else because they just developed it.
It's not. It's just being planned. The room next to me, they are still struggling with how to do it. I hope they can do it.
Well, I must have asked the right question for a change. There we go. Yeah, a couple more areas that I was sort of curious about as Aaron was talking to you. You talked about a Java client. So if I have Java, I have access to the full sending in SQL and getting answers and stuff back and copying data in and out. And then the other way of talking to it was the API over HTTP. Now that then sort of the next question that needs answering then is, do you have client libraries for open source languages to talk to this API?
Yeah, so the HTTP interface is pretty boring because curl in the command line, and that's not very convenient. We have a command line client that is written in Python, where you can use this command line. For Python, we have like the normal Python DB API, but also SQL Alchemy integration, Ruby, plain Ruby, but also Active Record. Then JDBC I mentioned. Node.js client is being developed by one of our users. This is like also community effort. And PHP, including PDO driver, is also in work by some PHP guys. And Scala, I think. Oh yeah, Scala. We have one guy doing it in Scala, and we have some people using it in Erlang.
Well, I know you had to have some weird languages in there. That was definitely, I knew that was coming, something like that. Did that also mean it would work well from, say, an Ajax environment if I wanted to use dynamic web pages with this?
Usually you don't connect directly to create, as there is no authentication mechanism and user management and stuff like that. It's really like a data store. So usually you connect to application server, and this application server is using like a trusted connection to the data store. However, what we have seen or what we've also done is like if you put Nginx in front of it and just a little bit of Lua code, then you can also expose it directly to the web and create a super fast backend for a JavaScript application.
Ooh, awesome. That's more and more like I want to play with. Speaking of playing with it, we did have another question from the chat room. Gray580 says, do they have a ready-to-use VM? I don't think you mentioned that.
Good point. Also scoop just for that, Joe. Docker image is pretty soon out there. Other than that, the installer is very, very easy. So, for example, if you fire up an Amazon instance, I think it's just one line, which is like adding our Yum repository and then Yum install, create service, create start, and that's it. So we decided against building images for all kinds of virtualized environments because it's so easy to install and even on your local machine. But Docker, because our team finds Docker pretty cool, we're gonna have a Docker image in 2 weeks' time.
Nice, another scoop. What a deal! This is right at the right time. You need to be on this show. This is great. And I was going to head somewhere else with that. Now my brain. So another thing is, reading through the documentation, I see copy to. So it's copying data out to a file. Mm-hmm. Where is that file? What machine does it copy it out onto?
Good, smart question actually. So every machine can store its dump on the local machine if you like to. So it's like a parallel copy to. So if you, let's say you want all the machines dump the data onto their local partition and then move it away, or you dump it to something like S3, for example. So you could dump it to S3, and then all machines in parallel would do the dump. It's not done on one machine where it is all serialized, so it's done in a parallel way, and you can specify a pattern on how the files are being created so that the files are not being overwritten by each other. So you don't receive a single file from a copy to, you receive multiple files from a copy to.
So copy to, I'm just guessing here, because one of the things that always comes up is how do I back up my data? I mean, it's one thing to use this in a test bed or just like for just to try it out, right? Temporarily, you might not want to back up your data, but as soon as you get into putting sensitive or real data in there, you're going to want to back it up. So is that what the dump is for then? Is that what the copy to command is being used for? Is to dump that data to protect the data for backup purposes?
Yeah, that's a very easy way to back it up and also back it up in a parallelized way, and also have the data not just being stored in a proprietary format. Of course, you can also back up the Lucene indexes and make a snapshot, LVM snapshot or whatever of the shards, but it's better to just store it in a native format. We also have on our roadmap something that is really cool, is like a point-in-time recovery feature. So what we could do, we're not doing it because we have not implemented it, but the underlying system is built in a way that you can do something like a save point, and then as we have a copy on write, or we are pending all the writes to the data store, you could also do something like a save point, and then you could restore the database like it was 1 hour ago, or 1 day ago, or 1 month ago. That's something to come regarding disaster recovery or things like that. But right now, copy to is the way to go.
Okay, yeah, that was going to be my next question, because I work for NetApp in my day job, and so a lot of what we do is, like with Oracle database, you can put it in suspend mode, right? So and then you can use like snapshot features of either the operating system, or in my case, the storage system can use a snapshot feature to make copies for development and reporting and things like that. So it sounds like we're not quite there yet, or at least it's a little bit more difficult to do without that save point feature that you just mentioned, right?
Yeah, so internally copy2 is doing something very, very similar. It's like creating such a save point and starting to stream out all the data. Meanwhile, the copy2 command is running, the system is still appending and writing and deleting and doing stuff like that. But that's the way how we deal with consistency. So even if you have a long-running query, for this query, the system is consistent all the time, and you can even persist that state. So the way it is built is done for that, but it's not exposed to the user interface right now.
So it would still work. In other words, I'm not going to get some sort of data corruption if I had to restore from that backup using the copy to, right? So the copy to is going to preserve consistency so that if I needed to, if my data center blows up, I can still, and I have that backup saved offsite, I can still restore that from that copy to and not have, hopefully, again, I mean, we're not really talking about transactional databases here, or are we?
So regarding transactions is, I said eventual consistent, but we are like on a document level, we are transactional. That means a document is written or is not written. It's not possible that document is being half written. And it's also that the system is consistent for a query. As I said, when I launch a query and it's probably taking longer than for that query, the system is consistent. And even if during that transaction or that read-transaction stuff is being written or deleted, it's not being affected. So it's kind of transactional. It's not like ACID compliant.
Right. Right. So a couple more quick questions. You mentioned a couple times the admin features, or I mean, so that kind of leads me to believe that there's got to be some easy way to administer this thing, right? Because there are some. It sounds like a lot of this stuff, which is great, is happening at least for now, auto-magically, if you will, in the background. In terms of, like you say, it detects if there's other nodes via multicast and things like that, which is great. But there must be some times when you have to go in and make some changes manually to adjust. Depending on what your workload is. So how do you do that? Is it all command line, or do you have a GUI?
Yeah, so we ship it with a GUI. It's a web-based administration interface. All the nodes have that GUI pre-installed. So you just connect to the HTTP endpoint /admin, and there you see the admin interface, and there you can you look at the node stuff. Other than that, we are exposing all the metrics also via SQL. So there's a sys table. It's like in Postgres. So you can look at how much disk you have available, what is the load of the nodes, and that stuff via the SQL interface. And that's basically like you would do with a normal database. And of course, you're also going to use some Linux tools to do basic monitoring of the nodes. But our vision is just to expose all of that stuff via SQL interface.
Yeah, that's great. That's great. We probably should have asked this up top, but if people are still listening, they're going to be wondering this at this point, which is, got to backtrack a little bit. Who is using this right now, and then what are they using it for? Like, could you give us some examples of who's using it and how?
Yeah, so we launched, I think, in May, which is like June, July, 3 to 4 months ago, where we just opened up our GitHub account. And basically, we want just people look at it. So we've been running our own service business before that, and using that stuff for 1-2 years for clients, but then decided to go for an open source project and do also more community-based approach, and also having more spread there. And since that, I think we've seen about 6,000 downloads or something like that, and people use it for various things. So one thing is time series data. Whenever people collect time series data in a larger amount and they need a scaling system, that works very well. So we can also partition data based on time, not only shard it in the one dimension, but also partition it in the other dimension. And that's something where we see that people are really using it. The other thing is also like rather real-time analytics, where they do aggregations over a larger data set. So let's say you have some sales reports or whatever, and you want to calculate the sum of one country, whatever. If you need this kind of map reduce queries, that's something a lot of systems cannot do. You can do it with Hadoop, but not if you're reading and writing at the same time. That's also the one thing we see. And the other thing is just using it as a MySQL replacement for a scaling web service, where they have a Django application, where they build an iOS application, and then they need a REST endpoint where they have their App Store thing that is probably tracking user movement or things like that. And they're building a REST API and user scaling backend. These are like the three main thing. So we also we are now putting some case studies online. Oh yeah, what I forgot to mention is like we put our stuff online and expected not really something to happen, but one of our users posted it on Hacker News, and that like made things going mad at our small company with 40,000 unique users or things like that. And we've seen the first people that this was like 3 months ago, they contacting us and said, well, we put your stuff in production and we're using it. So clearvoice.com is, for example, one company that is using it. There are some UK guys that are doing iOS applications. Basically, Malaysian guys, they're doing stuff in real-time ads. So various very interesting things people are doing. We never expected this to happen.
It's very good that you're eating your own dog food on this, because I was just going to ask if it was production ready. Clearly, it's production ready. You're in production with it. So,
yes.
And are you envisioning a consulting business around this, or maybe a freemium model where there'd be some version of it with more features? Or, I mean, this clearly can't be just a labor of love for you guys. There's clearly some profit model eventually, right?
Yeah, so that's also one of the reasons why we are on FLOSS Weekly. We are great believers in open source, free libre open source software. Been working in that space now for 10 years, also being a board of directors of the Zope and Plone Foundation and things like that. And we finally found, after quite a long journey, also some investors that support our vision of open source and business the way we are doing. So we're working with the guys from Sunstone Capital in Copenhagen, which are also behind Neo4j, and also the other guys are DFJ Esprit, a London-based office. And our model is basically to have an open core that is not crippled or limited in any ways, and is also with a liberal open source license. So it's Apache 2, which is like allowing the people to do basically whatever they want with the core. And on top of that, we're also planning some enterprise features that will be available for to pay for, like whatever encryption or advanced cross the globe spanning replication stuff, also parts of backup compliance features which we have in mind. This is not right now our main focus. Right now our main focus is really to establish the user base, also have a vibrant driver ecosystem going, and also probably having some people contributing to the core. And then later next year, I think we're also going to start some enterprise features. Other than that, we also offer subscriptions where you have extended support, where you can receive emergency patches or onboarding sessions. But right now we're not going to a hosted model, and it's also not that we are going to build a consultancy business out of that. It's really that we have now the freedom with our core team of 10 developers to really focus on the core of the system.
That sounds really, really awesome. I look forward to hearing more about this in a year when you've got everything a little bit further down the line there. We're almost out of time, right up against the wall here. Is there any one short thing you also want to make sure our audience knows that I forgot to ask?
Let me think.
That's always a tough question.
We
I'm
would
sorry.
laugh. It came probably too fast, but what we're really eager to hear is feedback from the community. So we have a pretty specific background. We've done projects working for big media houses, whatever. But to hear what the people really need out there, and also drop us an email, file a GitHub issue, hang out in our IRC channel. I think we're pretty easy to contact, but we would really love to hear from the people out there what they what they think about what we are doing and what features they need.
Very good, very good. And again, we're out of time. I would normally ask you 2 more questions, but I'm just going to leave that so I can get yelled at by my audience. Anyway, so thank you, Jodok, for coming on the show and talking about Create Data. This has been very fascinating. I know Aaron's gotten a lot out of this show as well. So thank you for coming on the show.
Thank you very much for having us.
Very good. Good. It was Jodok Batlogg, something like that. Close to that. Sorry. For Create Data. Aaron, what do you think?
Well, yeah, it's very exciting to me. I mean, this is the kind of thing where it's kind of like the best of both worlds, as I alluded to several times when I was asking my questions. It's really taking the way that this has developed. You know, people have been attacking this, you know, from one angle and attacking it from another angle. This problem of data storage and analysis, and this really brings all that together into one cohesive thing, and this could be the future of where we're going, and I think that they're really onto something here. Yeah, I'm excited. I've already got a list of people going here that I need to go to say, okay, go watch this interview, because you know, this could be the future of where data storage ends up.
Exactly. I had a similar feeling listening to this, and even just initially when they contacted me about being on the show, I went and looked at some of the information. I went, okay, this is impossible. This is the 2 impossible things put together. But it sounds like they've got a real good plan on that and a good handle on it. And the fact that they were eating their own dog food gives me enough assurance that I can go talk to my client here, because we've actually got a couple of problems that would be best solved by something like a NoSQL data store, but nobody wants to deal with that.
Right.
They want to deal with SQL because that's what they're familiar with, and maybe this is a really sort of the bridging app that they really need to do. So that sounds like a lot of fun. Speaking of bridging apps for things they want to do, let's talk about the upcoming guests. Next week, R Studio, which is a nice GUI for R, a data analysis language. A lot of people use it in all sorts of professions, broad professions. Now, I have to say, we're not going to be on next week, Wednesday. We're going to be on Thursday instead, same time, or 8:30 a.m. Pacific time, but it's going to be Thursday, not Wednesday. Turns out their power is going to be off in the studio, so apparently we can't do a show with all the power off. Even though we hold up flashlights and stuff, that's still not enough. You actually have to have the electronics running. So Thursday, not Wednesday for our studio next week. Then a couple weeks after that, we've got Usha. I got to spell it better, Ushahidi, which is extracting data from social media, extracting all sorts of information like correlated Flickr pictures and Instagram pictures, things like that, and taking the bigger picture out of that. We've got Squitch, which is database change management, all written in Perl with one of my fellow Perl guys, did all that. And Docker. We keep talking about Docker here and everywhere else, so we're going to get the head Docker dude on. He's going to talk about how Docker came about and where the state of the world is for that. Our Q3 is full. We have I'm opening up Q4 this week. I promised to do that last week, but I've been busy. You can go to the schedule up on twit.tv/floss. That's our homepage. There's a link there to our schedule. You can follow us at Floss Weekly on Google Plus and Floss Weekly on Twitter. We do have a live chat room. We took a number of questions from the chat room. The chat room was pretty excited about this project, so we had a lot of things going on there. You can follow me on Google Plus as Randal L. Schwartz. You can also follow me as Merlin on Twitter. Although that's mostly post only. I don't really interact very well with stuff on Twitter. I'm not going to be around for the next 2 weeks. I've got my lovely and talented panel of co-hosts. A few are stepping up into the host chair, taking over to make sure our next 2 weeks are actually full. I will be on my 72nd cruise. Mostly with all with Insight Cruises. No, mostly with Insight Cruises. 568 total sea days. That's just like almost 2 years. It's amazing. And as I've been announcing for the last couple of weeks, I do have a meetup scheduled August 23rd. That's a Saturday night, 7:30 p.m. at the McMinimans in Queen Anne Hill. If you're in the Seattle area, please come join us. That'd be a lot of fun. I'd like to meet people in person. There'll be some of the Perl people there and some open source people. And I'll be various places from Seattle to Anchorage and back on my cruise. Check my schedule out, or check the schedule out for SA22. Let's see, I don't know how to find that. Anyway, just ask me online, and I'll point you at my schedule. So that's all I have time for. Aaron, maybe you have like 30 seconds to plug whatever you want.
Thanks for that. You can follow me on Google+. I am plus Aaron Newcomb on Google+. That's where I hang out and talk about things, especially about things I'm making. And if you didn't know, I run a makerspace along with a lot of other talented people in my hometown of Benicia. So if you're in the Solano County or Contra Costa County area of California, you will want to check us out. That's BeniciaMakerspace.org.
Very good. And since I hear that music coming right up behind me, we'll see you again next week on Floss Weekly.